Built to be the rugged, go-anywhere future of commercial aviation, the Havilland Canada DHC-7 emerged to answer the call of airlines seeking to provide the travelling public with more direct access to air travel by opening up rural strips and inner-city airfields to widespread passenger airliners, and the DHC-7 was poised to be the face of this new market trend. However, the DHC-7 demonstrated the limitations of the technology of the 1970s when it came to delivering such an airliner. As one that was undoubtedly sturdy, the use of 4 engines and the failure of the STOL market to flourish as hoped by de Havilland's designers meant this machine would ultimately never reach its sales goals, but in its downfall would provide an object lesson as to how to create a dedicated STOL turboprop, which would come to pass as the far more successful -8. The de Havilland Canada DHC-7 emerged from a very particular moment in post-war aviation, when the idea of what a regional airliner should be was changing and, in some quarters, being actively reimagined. As in the years after the Second World War, civil air transport had grown rapidly but not evenly, with the great trunk routes between major cities being increasingly dominated by larger aircraft operating from long, well-equipped runways, while vast areas of Canada and many parts of the wider world still depended on modest airstrips, water aerodromes, gravel bars, and improvised fields. De Havilland Canada built its reputation not by chasing speed or glamour, but by solving the stubborn practical problem of access, and from the DHC-2 Beaver onwards, the company's aircraft became bywords for short takeoff and landing performance and operational ruggedness, with the Beaver, and later the Otter and their relatives, being not designed to impress on the ramp at international airports, but to earn their keep in demanding conditions where the runway might be a strip of compacted earth, a snowy clearing, or a lakeshore. By the mid-1960s, the Twin Otter had turned that expertise into a successful turbine-powered workhorse that could serve remote communities, industrial sites, and small airfields with an ease that larger airliners could not match, and also offering a level of reliability and performance that made it attractive to an emerging generation of commuter and feeder operators. At the same time, the wider market for short-haul passenger flying was filling up with a different class of airplane, one shaped by a different set of assumptions, and on busier regional routes, airlines were adopting larger, faster turboprops such as the Fokker F-27 and its license-built Fairchild version, alongside conversions like the Convair 580 and 600, and purpose-built types such as the Hawker Siddeley 748. These aircraft were efficient on established networks in conventional airports, and they set the expectations for comfort, capacity, speed, and climb performance in the 40 to 60 seat bracket, offering cabins that felt closer to proper airliners than to utility transports, and were supported by an operating environment that presumed good runways, decent approaches, and dependable ground handling. De Havilland Canada could not outpace them simply by scaling up what it already had, because the normal measures of success in that segment were not merely passenger numbers, but cruise speed, per-seat economics on standard routes, and compatibility with busy airport operations, and thus the company instead looked for an angle that played to its strengths and to a set of challenges it believed were coming. The thinking was that it could compete sideways by not matching the others on runway length and cruise performance, but by opening up a network of airports that those airplanes could not use easily or economically. And in that view, the real advantage would not be being the fastest between 2 big hubs, but being able to serve the places that sat awkwardly outside the main system, including smaller city centre sites, constrained airfields, outlying industrial communities, islands with short strips, and regions where runway improvement would be slow or politically difficult. That strategy was rooted in a broader set of planning ideas circulating in the late 1960s and early 1970s, when airport capacity was beginning to look like a limiting factor on economic growth in some of the world's busiest metropolitan areas, with congestion at major airports becoming a political and economic concern, and one proposed solution was to divert short-haul traffic away from the biggest runways and terminals. Rather than having a 100-mile hop occupy a gate and slot that could be used by a longer-haul service, planners toyed with the idea of moving that short-haul traffic to specialized facilities, and if city center STOLports and short stub runways could be created, then an aircraft with true airline standard capability but exceptionally short field performance might make high-frequency urban-to-urban flying possible without expanding the biggest airports and without pushing yet more traffic into already crowded airspace patterns. The concept called for an aircraft that could carry around 40 passengers from runways of roughly 2,000 feet, while still offering a credible stage length of several hundred nautical miles with a full load, while also implying a level of system maturity and dispatch reliability that would satisfy airline requirements rather than purely utility operations, including predictable performance, straightforward turnarounds, and the ability to function within commercial schedules. The looming issue of noise pushed the project in a direction that became one of the Dash 7's most distinctive features, and it did so for both practical and political reasons, with new restrictions and community pressure making it harder for aircraft operators to accept noisy approaches and departures, especially if the dream of near-city STOL operations was to have any chance of acceptance. De Havilland Canada's answer was elegant in principle but demanding in execution, and required the use of very large propellers turning at relatively low rotational speeds, with bigger discs delivering the required thrust without having to spin fast, and the reduced tip speed would cut the most intrusive part of the propeller noise, especially the harsh high-frequency components that carry and irritate. The goal was not absolute silence, but a markedly reduced noise footprint that could be marketed as neighbor-friendly and, crucially, could help an operator win permission to fly into sensitive sites, and it was this single requirement that would ripple across the design, as slow-turning, large-diameter propellers demanded careful integration with the wing and undercarriage, and they encouraged a configuration that could exploit prop wash over the wing to improve low-speed lift. This also influenced the way the aircraft would be flown, as a design that could achieve lift and thrust through large, slow propellers naturally lent itself to steep controlled approaches and decisive braking, aided by effective reverse thrust. When de Havilland Canada formally commenced the DHC-7 program in 1972, the company leaned hard on the proven house style that had served it well, with the new airplane being, in spirit, an enlargement and professionalization of the Twin Otter concept rather than a clean break from it, with a high-mounted, high-aspect ratio wing to keep the structure clear of debris and to produce generous lift at low speeds, a sturdy, practical airframe suited to rough field operation, and systems intended for airline service rather than bush flying. Yet the Dash 7 was not simply a scaled-up Twin Otter, with pressurization, essential for a credible regional airliner, demanding a change to a circular section fuselage, with the structural and manufacturing consequences that follow from building a pressure vessel, including hoop stresses, reinforcement at cutouts, careful attention to skin joints and frames, and a layout designed around a cabin that would be comfortable and quiet at altitude, as well as on approach into a short strip. The most consequential aerodynamic work centered on achieving both very low approach speeds and dependable control at those speeds, with the wing being given an elaborate high-lift system, with most of the trailing edge devoted to double Fowler flaps intended to provide large increases in lift coefficient, while also supplying enough drag to permit steep, well-controlled approaches into constrained fields. Rather than using the Twin Otter's flaperons, which drooped the ailerons with the flaps, the Dash 7's designers chose to keep the ailerons smaller and make room for more flap area, then restore and enhance roll authority through spoilers, while two sets of roll spoilers, operating in different parts of the speed envelope, provided the roll control the aircraft needed in the slow regime where a STOL airplane lives, with this architecture also lending itself to lift dumping on touchdown, helping the aircraft transition quickly from flying to braking, a crucial part of extracting short-field performance in the real world rather than on paper. The engine arrangement was equally bound up with the low-speed problem. As though a twin-engine layout would have been lighter and simpler, de Havilland Canada's STOL ambitions demanded that the Dash 7 be both safe and controllable at very low speeds, including after an engine failure, with 4 engines offering a different set of trade-offs, including a higher maintenance burden, but reduced asymmetric thrust in the event of a failure, and the ability to distribute propeller slipstream across more of the wing. That slipstream mattered, as with 4 propellers blowing a broad swathe of accelerated air over the wing and flap system, the aircraft could generate the lift it needed at lower true airspeeds, and it could do so with better handling margins than a comparable twin, with the chosen power plants being Pratt & Whitney Canada PT6A series turboprops, developed in a form that suited the Dash 7's noise and propeller requirements, with each engine providing roughly 1,120 shaft horsepower, and the gearbox and propeller system were matched to the program's central promise of high thrust at low propeller rotational speed. Structurally, the configuration that emerged by the time the prototypes were being built was a study in purposeful compromises, with the high wing, while ideal for clearance and low-speed lift, requiring a strong center section and carry-through structure, integrated with a pressurized fuselage, while the undercarriage had to be robust for short-field and rougher operations, yet also retract cleanly to reduce drag in cruise. The solution was a landing gear arrangement that folded forward into the inner engine nacelles, keeping the gear bays out of the pressure vessel and allowing a practical layout without sacrificing the cabin, while at the rear, the tailplane was carried on a prominent T-tail, with this being a response to the aerodynamic environment created by 4 large propellers and a wing designed to operate at high lift coefficients. By placing the horizontal tailplane high, the elevator was kept clear of disturbed airflow and prop wash during the most critical phases of takeoff and landing, helping to preserve pitch control when the aircraft was slow, heavily configured, and close to the ground. And by early 1975, the first prototype was developed as an 80-foot class fuselage, sized for a 50-seat cabin, a long wing spanning roughly 93 feet, and 4 nacelles with large, slow-turning propellers, with the typical seating arrangement being a 2x2 layout that balanced passenger comfort with the economics of a commuter airliner. The prototype was unveiled at the Havilland Canada's Downsview facility on February 5, 1975, and on March 27th it carried out the type's first flight, with contemporary accounts routinely crediting de Havilland Canada's chief test pilot, Robert H. Fowler, at the controls. Momentum continued quickly, and a second prototype followed into the air on June 26th of the same year, with the flight test effort focusing on validating the aircraft's quiet running, with Transport Canada certification being awarded on May 2, 1977, though even with certification in hand, entry into airline service took time, as operators prepared routes, crews, and maintenance arrangements for a 4-engine commuter type unlike anything else in its category. The breakthrough came with Rocky Mountain Airways of Denver as the launch customer, with the Dash 7 entering service on February 3, 1978, while in September of the same year, the airliner was displayed at the Farnborough Air Show, placing its short-field persona in front of European operators, officials, and observers who were watching similar debates about noise, access, and airport capacity. However, the STOLport revolution originally envisaged by de Havilland's designers would fail to materialize due to the influence of 2 major events in the commercial aviation industry, the most prominent being the 1979 oil crisis, while similarly disruptive was the deregulation of the American airline industry during 1978. The oil crisis pushed the price of fuel up exponentially, together with the cost of living, and in response, major carriers became skeptical about the prospect of investing heavily in new and largely uninvestigated sectors of the industry, while fewer passengers were flying, while deregulation, though giving rise to the potential for new startup airlines to procure the Dash 7 in vast quantities to support their routes to untapped destinations, meant most of these carriers were short in capital and thus procured second-hand airliners such as the Convair 580, the NAMP YS11, and even aging Douglas DC-3s and DC-4s. Therefore, during its initial sales run, the Dash 7 was increasingly positioned and increasingly purchased as a quiet, relatively spacious 50-seat commuter airliner that could cope with awkward runways, steep gradients, hot and high conditions, icing, and marginal weather, while still fitting the hub-and-spoke habitats of deregulated regional flying, with de Havilland Canada's own reports noting that the US-based fleet was flying short sectors of around 140 miles on average at high utilization and with very strong day-to-day operational dependability, with dispatch reliability being reported at 99.1%. The buyers who actually signed for new aircraft in the early 1980s were, accordingly, mostly commuter and regional carriers, including Air Wisconsin, Atlantic Southeast, Golden Gate, Hawaiian, Henson, Ransom, Rio Airways, and Time Air among the North American recipients of new Dash 7s, while elsewhere in the world, Windrow in Norway, Maersk Air in Denmark, Arkia in Israel, Air New Guinea in Papua New Guinea, and others acquired numerous examples. In the UK, the Dash 7 became a fixture of the British commuter scene through the purchase of 12 units by Brightman Airways, which operated the type from its headquarters at Plymouth Airport to various destinations across Britain, Ireland, and parts of Europe, while Air Greenland operated 4 Dash 7s between 1979 and 2015 to work across the vast Arctic network of the flag carrier. However, by January 1985, only 100 aircraft had been delivered, at which point the airliner's sales curve flattened due to the widely anticipated build-out of dedicated STOL facilities largely failing to materialize, and without a dramatic expansion of short-runway city center airports, the Dash 7's unique capability was less often the decisive factor in fleet planning. Many airlines discovered that they were paying for capability they seldom used, and the 4-engine layout, which made the Dash 7 forgiving at low speeds and helpful on short fields, also meant more inspections, more components, and more maintenance events than twin-engine competitors, an economic penalty that commuters felt acutely once the early excitement faded and fare pressure tightened. Where the Dash 7 did enjoy something close to a decisive competitive advantage, it could become almost synonymous with the airport it served, and that was commercially important even if it did not translate into hundreds of additional sales, with the best example being with London City Airport, which began operations in the late 1980s, and through the combination of a short runway and a very steep approach of 7.5 degrees, meant only a limited set of aircraft could use it. The Dash 7 had been instrumental in the development of London City. As an example, operated by the regional carrier Benign Airways, had been used to demonstrate that the former wharves of the London Docklands could feasibly be converted into a regional inner-city airport, with June 27, 1982, seeing Captain Harry G. and co-pilot Charlie Beelby take off and land using Dash 7 Golf Bravo Romeo Yankee Alpha on the cleared expanse of Heron Quay. The opening of London City Airport in October 1987 caused a significant stir in the feasibility of the STOLport concept, and to quickly exploit this, British Midland Airways developed a short-haul subsidiary airline dedicated to work from the new facility, initially called Eurocity Express, before being renamed in 1988 to London City Airways, which itself employed 3 Dash 7s new from the factory, which would turn out to be the last examples delivered. A similar built for the Dash 7 case occurred in Hawaii, where Kapalua Airport on the island of Maui opened on March 1, 1987, and Hawaiian Airlines operated Dash 7 flights to Honolulu from the start, taking advantage of the type's ability to lift a meaningful passenger load from a short runway. However, despite this last-minute success, the mid to late 1980s brought a marked shift that the Dash 7 was ill-suited to resist, as with newer 40 to 60-seat turboprops arriving in the form of the ATR-42, which offered more speed and range with lower operating burdens, de Havilland Canada responded with the twin-engine Dash 8, which entered service in 1984 and was explicitly developed from the Dash 7 with improved cruise performance and lower operating costs, trading away the extreme STOL edge. The logic was that carriers wanted the Dash 7's general regional utility, but not the cost of 4 engines, and they wanted a quicker airplane that could stretch to longer sectors and fit better into dense schedules, while the competing ATR-42 and Fokker 50 reinforced the industry's move towards efficient twin-engine designs in the same general capacity class, and it was against this backdrop that the Dash 7 increasingly looked like a specialist solution being asked to compete in a generalist market. With commercial performance having slowed to a crawl, production ultimately ceased in 1988, and the type's mainline commercial presence became a patchwork of second-hand aircraft moving between operators, alongside a gradual drift into special mission and governmental roles that took advantage of its payload, low-speed handling, and runway flexibility, with a total of 114 examples eventually being constructed. In the United States, the Army adopted the Dash 7 as the basis for its airborne reconnaissance low family, turning a civil STOL airline into a low-profile intelligence platform, initially contracting for Dash 7 intelligence conversions that were awarded to California Microwave Incorporated in spring 1991, with the first ARL aircraft being delivered roughly 2 years later. The Army itself described the EO-5C ARL-M as a legacy manned multi-sensor aerial intelligence, surveillance and reconnaissance system based on a modified Dash 7, integrating communications and imagery intelligence with radar capabilities, with its benign handling at low speeds, multi-engine redundancy and generous internal volume, making it a stable, adaptable host for complex sensors and onboard workstations. In parallel with military conversion, the Dash 7 became a specialist tool for civil states, particularly where geography and public responsibilities demanded aircraft that could do more than simply transport people from A to B, with the British Antarctic Survey's adoption of the type being a particularly vivid example of the aircraft's long second act, with the first Dash 7 arriving in Antarctica in 1994. However, with Dash 8s continuing to roll off the production line in enlarged and enhanced forms at competitive prices, second-hand Dash 7s, with their small numbers and bespoke maintenance requirements, fell quickly out of regular work, and by the late 2010s and early 2020s, the Dash 7's presence in mainstream airline fleets had largely become history, with September 2024 seeing a total of 19 examples still in use, 10 in regular commercial service, while the rest are under military or government use with the US Army or the BAS. The Dash 7 was also involved in 10 accidents and incidents, resulting in a total of 68 fatalities, the first being on May 9, 1982, when Al-Yamda-owned Dash 7-103, 7 Oscar Alpha Charlie Kilo, crashed into the sea short of the runway at Aden International Airport, resulting in the deaths of 23 of the 49 on board. The worst accident involving the Dash 7 took place on May 6, 1988, when Windrow Flight 710, operated by Dash 7-102, Lima November Whiskey Foxtrot November, crashed into the mountain of Torghatten in Norway, while on approach to Brønnøysund Airport, killing all 36 aboard, with investigations concluding that the pilots had begun their descent 4 nautical miles too soon during foggy conditions, and thus flew below the safe terrain clearance altitude. The most recent accident involving a Dash 7 took place on May 1, 2006, when a Trans-Capital Air Dash 7-102 crash-landed at Swerdru Airport in Liberia after its landing gear failed to extend, though all 40 on board, including 36 Ethiopian soldiers, were unharmed. In the end, the de Havilland -7 is an airliner that didn't lose to the -8 or to competing commuters, but was simply an airliner a decade ahead of its time, being built for a market that wasn't ready for the proliferation of STOLports across the globe, and thus found little mainstream traction upon its initial entry into production and service during the late 1970s. By the time the 1980s arrived, however, the demand for STOLports like London City arrived in earnest, and the -7 was clearly the product of an earlier school of thought, with its four-engine design now being seen as a needless complication that could easily be circumvented by twin-prop alternatives, and thus even in the era for which it was designed, the -7 was quickly pushed out of the market it had been instrumental in improving, becoming a sturdy and practical obscurity in the wider aviation scene that is often overlooked for proving the concept of the modern STOL turboprop.